Now we will start the exercise number 6.5. First question, it is very easy, that you can check by your own. Second question I will take up, that a PQR is a right angle triangle and right angle at P, and M is the midpoint on QR such that PM is perpendicular to QR. So that PM square is equal to QM into MR. What is given? PQR is a right angle triangle. At P it is 90 degree. Means this angle is 90 degree. From P perpendicular is dropped on QR and this point is M. This much is given. So as we have done previous two examples for solving the Pythagoras theorem, and before that also whatever I had given, so this is quite related with that kind of concepts which I have already taught to you. So let this angle be X and this angle is Y, and then this angle become Y and this is X. Proof of this I have already given to you. Here PM square is equal to QM into MR. This is to be proved. So here we will see QM and MR, these are these two triangles and PM is common in both. So we will use the property of similarity of these two triangles, means PQM and PRM. We will take the similarity of these two triangles. So for solution, it is very important how to proceed towards the solution, means what is to be proved and which sides are here and which triangles should be taken similarity, because there are three triangles over here. So which triangle to be taken for the similarity, use the property of similarity. So it depends what kind of question is there, what is asked in the question. On the basis of that only we will select the triangles for similarity in this particular question. So in triangle PQM, in triangle PQM, the corresponding vertex, we will name the triangle with the corresponding vertex itself, so that there won't be any problem later to find the ratio of the corresponding sides. So PQM. So if P is the vertex with angle Y, so PMR, which angle is Y? That is vertex R. So we will take vertex R first. Q is X, then we will go for P and later M is common in both. So in these two triangles we will study. So here angle PQM is equal to PQM, it is X, so that is RPM, that is angle RPM, right? And QPM, angle QPM is equal to QPM, that is Y, that is PRM, angle PRM. Therefore these two triangles are similar, therefore triangle PQM is similar to triangle RPM. Since I have named this triangle corresponding to the vertices, so writing the ratio of the sides won't be a big problem. By a criterion of similarity. Why do I write step by step? Because in the exam you are supposed to write stepwise. Even though these two triangles are similar, you cannot write directly. You have to write step by step. You have to prove that these two are similar under the certain criterion of similarity. So we have taken criterion of similarity as A criterion. So these two triangles are similar. Now triangle PQM is similar to triangle RPM. The ratio of the corresponding sides will be equal. So you will see what is called PM square is needed. So you will see PM, this side corresponds to RM. So therefore PM upon RM is equal to, again we want PM. So QM corresponds to PM of this triangle, right? Therefore QM upon PM. The ratio of the corresponding sides of these two triangles will be equal. So by cross multiplication we will get PM square is equal to RM into QM. So QM into MR, RM can be written as MR, or PM square is equal to QM into MR. That is proved. That is proved. So this way, which triangle is to be considered, that is to be learned. Accordingly, we should proceed. We will go for the next question. Now we will take question number 3 of the same exercise. In figure ABD is a triangle, right angle at A and AC perpendicular to BD, so that these are the 3 things which is required to be proved. Given ABD is a right angle triangle, AC is perpendicular dropped on BD. So, as we have done in the previous 2 examples, so here we will see that if this angle is X of ABD and this angle is Y, then this angle will be Y and this angle will be X. This we have already done in the previous theorems and exercises and all. So with this we will prove these 3 relations. So here first relation is, we will take the first part. AB square is equal to BC into BD. AB square is equal to BC into BD. You see, BC is the side of the triangle ABC and BD is the side of triangle ABD. So we will select the 2 triangles ABC and ABD. But naming will be done according to the corresponding angles. So in triangle ABC and big triangle we will take. So you see, A I have taken for the small angle. So A of this triangle corresponds to D of the big triangle, because this is Y and this is Y. So we will write triangle D. Then B we have taken. B is X. So X is in the big triangle. This X is of course common in both. So we will write B. And for C, that is ABC. C is 90 degree. So 90 degree is A. So DBA, this will be the name of the triangles with corresponding vertices. This is very important. We are taking corresponding vertices. If these 2 triangles are similar, then finding the ratio of the corresponding sides will be very easy in this case. So we will see ABC, angle ABC is equal to angle, that is for the big triangle ABC, and is equal to ABD for the big triangle, that is angle ABD. Second angle we will take, suppose we are taking BAC, angle BAC of the small triangle. BAC is Y. For the big triangle, that is ADB, that is angle ADB. 2 angles, the 2 corresponding angles of 2 triangles are equal, then these 2 triangles will be similar. Therefore triangle ABC is similar to triangle DBA by a criterion of similarity. See how simple it is. Once similarity is known, 2 triangles are similar, you know it, then corresponding ratio of the corresponding sides will be equal. So we want AB square, so we will take AB over here. So AB upon DB, right? Again we want AB in denominator, that is AB over here. So BC upon BA or AB, the corresponding side. BC corresponds to BA, so this way we can be written. So BA is AB simply, so we will write AB square is equal to DB into BC, that is DB into BC. Or we can write AB square is equal to BC into BD. This is the first part is proved. Similarly, we will go for the second part. Here, AC square is equal to BC into DC. AC, then BC, then BC and DC. See, here, you must tell the children which two triangles should be considered over here. BC belongs to this triangle, DC belongs to this triangle, and here AC is common in both, so we should take the small two triangles, these small two triangles, right? We should take these two triangles, and according to similarity we take the name the vertices, and so that afterwards ratio of the corresponding sides, taking that is very easy for us. So we will write in triangle ABC and triangle. Now we will see the corresponding vertices. A is angle Y. It corresponds to D for this small triangle, right? B is X. X corresponds to A for this triangle. So DA. And finally C is common in both. So I have written these two triangles in terms of the corresponding vertices. So you should remember this. Now we will show that these two triangles are similar. We'll have to prove it first, then only we can proceed. Even though we know that these two triangles are similar, but when we are solving the question, so we are supposed to show that these two triangles are similar. So there go. Angle ABC, that is ABC, is equal to, it is X. X is CAD. Angle CAD. And angle CAB, that is CAB. CAB is Y. Y is ADC. Angle ADC. So two corresponding angles of these two triangles are equal. Therefore, these two triangles will be similar. Therefore, triangle ABC is similar to triangle DAC. Then we will go for the corresponding sides. Ratio we will take. So what is required? AC. So we talk about AC, A and C. Therefore, AC corresponds to BC is equal to, we want AC in denominator. So AC over here, so we will write BC upon AC. This implies AC square is equal to DC into BC. That is there. DC into BC. So this is proved. Similarly, third one, it is a homework. You can do by your own. Which way? Here it is AD. So AD is this, BD is this, CD is this. So in this case, we will have to consider two triangles, of course, two similar triangles. One is this one, another is the big one. Means ABD and ACD. These two triangles, if you consider, you can get this relation. You can prove it by your own. So, my dear friends, we will take the question number 4 over here. Third we have already done. Solution. ABC is an isosceles triangle, right angle at C. Prove that AB square is equal to AC square. I am attempting this problem over here since it is in the sequence given, but question is very easy. You can apply Pythagoras theorem and you can get the solution by your own. But still, since I have taken, I will solve this problem. ABC is a right angle triangle, right angle at C. Since it is isosceles triangle, means two sides are equal. Remember that these two sides can never be equal because it is the hypotenuse. The length of the hypotenuse is always greater than the remaining two sides. So we cannot take AC is equal to AB or BC is equal to AB. These two sides may be equal, right? Is it clear? Now we will proceed by Pythagoras theorem. By Pythagoras theorem. What is Pythagoras theorem? That in right angle triangle hypotenuse. In right angle triangle, hypotenuse square is sum of the squares of the remaining two sides. Therefore, AB square is equal to AC square plus BC square, right? Therefore, AB square is equal to AC square plus AC square, since AC is equal to BC. Therefore, AB square is equal to 2 AC square. There was nothing in this questions. Since I had written, so I attempted. This could have been done by you also. So students, in this question what is given? Given that this ABC equilateral triangle, means all the sides are equal and side is 2A, means this is 2A, this is 2A, and this is also 2A. Find the altitude. What is the altitude? If you draw perpendicular on this side, opposite sides from any vertex, they suppose D is called the AD is called the altitude. Solution. There are 3 altitudes. From here if you draw perpendicular, 1 altitude. From here if you draw another altitude, and from here 3rd altitude. And fortunately, length of the altitude in all the 3 cases will be equal, since it is an equilateral triangle. So we will find one, and that will be same for all. So here we have brought perpendicular, given triangle ABC is an equilateral triangle. It's an equilateral triangle, and AD is an altitude. We have to find AD over here. So, in triangle ABD and triangle ACD, see, AB is equal to AC because it is equilateral triangle. AB is equal to AC, since ABC is equilateral triangle, and this angle will be equal to this angle, and angle ABD is equal to angle ACD, right? And AD is common side. So of course it is 60 degree. So these conditions mean these 2 triangles will be congruent. Therefore, triangle ABD is congruent with triangle ACD. These 2 triangles will be congruent. Therefore, corresponding side BD is equal to DC. BC is equal to DC is equal to A, because it is 2A, so this will be A and this will also be A. So it is very good result we got, and after that we can apply Pythagoras theorem to get the side AD. Further, by Pythagoras theorem, in this triangle we will say, in triangle ABD, this will be hypotenuse because this is 90 degree and remaining 2 sides are these. Therefore, AB square is equal to AD square plus BD square. Very simple. We are applying the Pythagoras theorem over here. Put the values. AB square, AB is 2A. So 2A square is equal to AD. AD is to be found out. AD square plus BD is how much? A. That is A square. Therefore, this will be 4A square is equal to AD square plus A square. If you transfer this, then we will get, therefore AD square is equal to 3A square. Therefore, AD is equal to A root 3. This is the answer. So finally we got the answer. This is the altitude, AD is A root 3, and for the remaining altitude also, since it is equilateral triangle, all the altitudes will be equal and that will be equal to A root 3.